Hello, and welcome to my presentation on the Johnson-Corey-Chaykovsky reaction. Now initially I'm going to discuss who these people actually are. Now first of all we have A.W. Johnson and Michael Chaykovsky. Now I wasn't able to obtain any biographical information on these two people whatsoever, although I was able to find journal articles associated with them. A.W. Johnson more or less exclusively worked on electrochemistry, whereas Michael did do work on these. He also worked on ketone synthesis and also worked with amines too. Although Chaykovsky was also quite involved with E.J. Corey in the 60s, where they worked together on electrochemistry and published an article on this reaction during this time. E.J. Corey himself was born on the 12th of July 1928 and was associated with Harvard University, where he later won the Nobel Prize in 1990 for his work in organic synthesis and methodology. But what is the reaction we're going to be talking about here? Well, generally we take a sulfur halide and react it up with an electrophilic species, such as a carbonyl group, so an aldehyde or a ketone. And we then come out with the epoxide or cyclopropane. Now in this presentation we're going to be focusing on the epoxide formation rather than the cyclopropane formation here. But how do we get this reaction to undergo itself? Well, to create the sulfur halide, we will take DMSO, so dimethyl sulfoxide, and react it up with methyl iodide. We will then create the trimethyl oxosulfonium iodide salt. We then react this up with sodium hydride, a strong base, to create the halide itself, so dimethyl oxosulfonium methylide. Although what can happen in this structure is that resonance can exist. So the electrons from the double bond are just pushed onto the carbon atom to form the carbon ion in this process. Although another halide which we'll be using in the reaction mechanism on this slide is dimethyl sulfonium methylide, synthesized in quite a similar way and also exhibits a very similar resonance between the sulfur and the carbon atom. Now, in the reaction mechanism, what will happen is that the lone pair from the carbon ion will be used to attack the electrophilic center on the carbonyl group in benzaldehyde, and this being due to the nucleophilicity of the carbon ion. The electrons from the double bond will then be pushed onto the electron sink, the oxygen atom. This will result in the following intermediate, where the lone pair from the oxygen atom will now be used in an intramolecular attack to kick out dimethyl sulfide as a leaving group. Now, because dimethyl sulfide is a good leaving group, it will thus leave and create the epoxide as the other product. But where can these oxyranes be used? Well, one is in the production of ethanolamines, which can be used to create ethanolamine soaps. And these can be used in the production of shaving creams because they can be used to soften the hair on the face. Now here is a picture of what ethanolamine itself would look like. Although oxyranes can also be used in the production of polyethylene glycols. These can be used to create gels that can store and release drugs. Now here's an example of what one of these gels would look like. And lastly, they can be used to create epoxy resins, or better known as adhesives. Thank you for watching my presentation.